simultaneous equations. We'll be finding the coordinates of the points of intersection here of a linear graph with different non-linear graphs. So we could have a parabola and, a straight line. We could have a cubic and a straight line or whatever. Find the coordinates of the points of intersection of the parabola with the equation y equals x squared minus 2x minus 2 and the straight line with equation y equals x plus 4. Now remember, the point of intersection of something means where they meet. So in this point, the x and the y is exactly the same. So because this one is y equals and this one's y equals as well, we can just equate. And we get x squared minus 2x minus 2 equals x plus 4. And now move them over to the same side, so we get x squared will be minus 3x minus 6 equals 0. I have to factorize this one. Can't factorize this normally, so I'm going to use the quadratic rule. X equals minus b plus and minus the square root of b squared minus 4ac all over 2a. If I get 3 here plus a minus 9 minus 4, a is 1 and c is minus 6, all divided by 2 times 1 is 2. So I get 3 plus and minus the square root. This becomes 33 all over 2. And then I'll need to find the y. Okay, now you can find the y by substituting. X equals 3 minus the square root of 33 over 2 into y, and we get y equals 3 minus the square root of 33 over 2 plus 4, and you'll get this point, y equals 11 minus the square root of 33 over 2, and if you sub x equals 3 plus the square root of 33 over 2, you end up getting y equals 11 plus the square root of 33 over 2. Therefore, points of intersection are, the first one was the x of 3 minus the square root of 33 divided by 11, and 11 minus the square root of 33 over 2. Not 11, it's 2, sorry, oops. And then that's point A, and point B you don't have to label them. This one is 3 plus the square root of 33 over 2, and 11 plus the square root of 33 over 2. You can do it on your calculator by going to that solve system of equations that we showed you, and then typing them in, solve for x and y, and you get your points. Number 18. Find the point of intersection of the circle with the equation and the line with this equation. So again, we will equate them, but before we equate them with this one here, x minus y equal to 0, we're just going to say x equals y, y equals x, it doesn't really matter. And we're going to substitute into, I've got to label these, number 1, number 2, into number 1. So instead of a y, I'm going to put an x. Instead of an x, you can put a y. It doesn't really matter. I'm just going to go the other way, only because I've got y here by itself. So I've got x minus 4 squared. Y is x, so plus x squared equal to 16. Expand, so I get x squared minus 8x plus 16 plus x squared minus 16 equals 0. So I'll get 2x squared minus 8x equals 0. Factorise, taking out a factor of 2x, x minus 4 equals to 0. Therefore, x equals 0 or x equals 4. Sub x equals 0 gives us y equal to 0, and when x equals 4, we get y equal to 4. So the points of intersection are 0, 0, and 4, 4. Example 19. Find the point of contact. It says here point of contact, and the straight line with equation and the curve xy equals 1. Now this curve over here is actually y equals 1 on x. So really, if I was to graph this, there's my x and y, I have this type of graph, and this line will touch one of these somewhere. Let's just say it touches it right there. That's what that means, point of contact. So I can rewrite it. It doesn't really matter. Oh no, I'll substitute. I'll say sub y equals 1 on x into equation number 1, and I'll label this, that's number 1. So I get 1, I'll just write it as x on 9, y is 1 on x equals 2/3. Okay, so if I times everything by x, I'm going to get x squared on 9 plus 1 equals 2x on 3. Alright, I'll put times everything by 9, so I get x squared plus 9, or equal, when I times this one by 9, that cancels, that would be 3, so 6x. So I'll get x squared, I'll write that again, x squared minus 6x plus 9 equals to 0, which factorizes down to x minus 3 all squared equals 0. Therefore x equals 3. Okay, if x equals 3, y will equal 1 on 3. Therefore, point of contact is 3 and 1/3. Better close my brackets. Again, you can do that on the calculator the same way. Solve system of equations, substitute them in, and there we go. Example 20. Find the coordinates of the point of intersection of the graph, which is a parabola, and another parabola. Here we've got 2, so this is a negative parabola, this is a positive parabola, so we've got one like this, so we're going to have 2 points that actually cross over. Again, point of intersection, we can equate, and we get negative 3x squared minus 4x plus 1 equal to 2x squared minus x minus 1. Bring them all over, I'll bring them all and make them positive, so I get 5x squared minus x plus 4 will give us plus 3x minus 1 minus another 1 will give me minus 2 equals to 0. Hopefully this factorizes. I'll have minus 2 in here, plus 1, that gives me plus 5, minus 2 gives me plus 3, there we go. Therefore 5x equals 2, x equals 2/5, or x equals negative 1, and when x equals negative 1, y equals to 2, and when x equals 2/5, I get y equals 2 times 2 squared is 4, 25 minus 2/5 minus 1, and that will give me minus 27 over 25. Therefore, points of intersection are negative 1 and 2, and 2/5 negative 27 over 25.